With an estimated 200 billion stars and a circumference of more than 100,000 light-years, what do we actually know about our own galaxy? To begin, astronomers have discovered a massive structure in our home galaxy that is 16,000 light-years in size. They also discovered that the strange gravitational monster at its center has undergone something that remarkably demonstrates the primal forces of the cosmos to us. The Milky Way, well, apparently you never stop learning even on your own galactic doorstep. In fact, in recent months, experts have gathered a series of spectacular insights that shed a whole new light on the Milky Way, and this even starts with a very fundamental point. After all, the latest data suggests that we have been categorizing the Milky Way incorrectly all along. Here's a quick quiz question. Why is the Milky Way actually called the Milky Way? According to an old myth, the reason our galaxy still has the word milk in its name is because of the ancient Greeks. When we look at the starry night sky, we see nothing but the goddess Hera's breast milk spilled, a milky pattern that applies to all galaxies, not just our own. After all, the ancient Greek word galaxias means milk. However, if we look at the astronomical facts instead of ancient mythology, we realize that the so-called milk of the gods is actually nothing more than star clusters scattered with light and dark nebula. From our perspective, the Milky Way is simply too small to be seen in its entirety, but astronomers have previously been able to create a general image of our home galaxy. This Milky Band, which rises in the southern sky on clear summer nights, is by no means representative of the entire galaxy. The Milky Way is a barred spiral galaxy with 5 theonomous loose spiral arms, 2 of which are visible in the sky. Its diameter is estimated to be 100,000 light-years, but its thickness is only 3,000 light-years apart from its center, which explains why the latter is roughly 16,000 light-years thick. Because of the many dark clouds that act as natural blinders to us with their interstellar matter, the actual heart of our galaxy is hidden from our earthly eyes. Nevertheless, it is now accepted that a fully grown monster is indeed hiding at the Milky Way's core. Sagittarius, contrary to popular belief, a star is a supermassive black hole with more than 4 million solar masses. In fact, experts now assume that nearly every galaxy center is adorned with such a supermassive gravity monster. As for the much smaller stellar black holes that form from collapsing stars, experts estimate that there are about 100 million of these strange formations in the Milky Way. However, astronomers' estimates vary greatly, with some estimating that our home galaxy contains only 100 billion stars. Others suspect that it's home to as many as 400 billion blazingly bright celestial bodies. And given that data from the Kepler mission and other studies suggests that there are on average 1 to 2 planets per star, there could be between 100 to 800 billion planetary worlds in the Milky Way. But not every one of these planets resembles a cosmic twin of the Earth, which is obvious, and yet in 2022, researchers from Nottingham determined that as many as 36 advanced civilizations could have developed in our galactic home system mice identifications and gigantic magnetic halos. Just as in the case of the Earth and the solar system, the Milky Way is not a galactic laner either, but an integral part of much larger overarching structures. On the one hand, the Milky Way belongs to the local group, and thus to a galaxy cluster that has about 35 members. On the other hand, the local group is itself part of the Virgo supercluster, a supercluster of galaxies that is itself part of the Lanaka supercluster. In other words, the local group, including the Milky Way, is subject to the influence of the colossal Lanaka supercluster, or at least that's what we thought until now. In theory, these attractors act as gravitational wells that draw galaxies towards them over a wide area. Much like the geography of a landscape determines the course of a river, the study that had assigned the local group to the Lanaka supercluster was based on data from the Cosmic Flows 4 survey, which included 56,000 galaxies within a radius of about 1 billion light-years. However, a new map of the gravitational catchment areas in the local cosmos now suggests that we have been misplacing our galactic home for a long time, and that it actually belongs to the much larger, shapely supercluster. In the end, it led to the discovery that there are 17 large gravitational wells in our cosmic neighborhood, and that the Milky Way's flows prefer to flow towards the Shapley supercluster. As shown in the figures, this means that nearly 60% of the structures are flowing towards the Shapley supercluster, whereas only 40% of the Lanaka supercluster. Overall, this finding gives astronomers new insights into the gravitational landscape of our local universe, but the phenomenon recently discovered by experts at the ends of the Milky Way bar is also entirely new, because we now know that massive magnetic structures that are more than 16,000 light-years old originate there. The unique origin of these magnetic filaments, which rise both far above and below the galaxy's plane simultaneously, also offers a clear indication of their genesis, since they come from the outer regions of active star formation rather than the galactic core. Scientists believe that we are dealing with a supernova's aftermath. The collision of the giants may be the cause of both the magnetic filaments and the equally potent radio structures that extend well beyond the stellar disk of our home galaxy. In fact, the combined effect of overlapping stellar explosions can eject material at speeds of up to 1,000 km/s, creating the galactic winds. How Sagittarius, although there is a supermassive black hole at the center of the Milky Way, as was previously mentioned, it is not a quasar, a term used to describe active galactic nuclei that emit enormous amounts of energy and even outshine all the stars in their home galaxy Sagittarius. A star merging with another black hole should be avoided to avoid confusion. However, despite all of the inactivity, our supermassive black holes keeps the specialists alert. A star, on the other hand, has long ago entered cosmic retirement, and now only the enormous bubbles and chimneys of gases and gamma rays stand witness to its past activity. The observations and data of the Event Horizon Telescope, EHT for short, have revealed that the mass monster is rotating at an astonishing speed and is also tilted against the plane of the galaxy conversely. However, this finding is also linked to a real astronomical problem, because if the data are correct, they are in stark contradiction to our models of the growth of supermassive black holes. These models suggest that the bizarre giants draw from the material of their own host galaxy, and thus move at about the same speed and at the same level as it. To find out why Sagittarius AR is now breaking this pattern, the researchers have once again combed through the EHT data in more detail and simulated several scenarios based on it. The aim was to determine which evolutionary history could best explain the current characteristics. And at the end of the research series, an astonishing result was obtained, since the usual accretion models are not sufficient to explain the observed properties. The astronomers came to the conclusion that Sagittarius A star must have collided and merged with another massive black hole in the distant past. In this regard, the reconstruction showed that the collision partner had about 25% of the mass of Sagittarius A star and was almost perpendicular to it. And although the Milky Way's black hole was 4 times more massive than its counterpart, the merger had a significant impact. The incorporation of the smaller partner, which had previously graced the center of a dwarf galaxy, dramatically changed the speed and rotational alignment of Sagittarius. Simultaneously, a star in the smaller galaxy spun lightly in the other direction and traveled perpendicular to the Milky Way. Additionally, the information shows the precise time that the black hole merger must have occurred, which is entirely in line with our own galaxy's known history. This indicates that the Milky Way collided with the dwarf galaxy Gaia Enceladus approximately 10 billion years ago. The two black holes collided approximately 1 billion years after the galaxy merger, and after the waves of cosmic tumult had subsided. The rotation speed and inclination of Sagittarius and the galactic mass ratio in this case was also 4.1. Additionally, the merger had an inclination of 145 to 180 degrees with respect to our line of sight. In other words, the galactic close encounter 10 billion years ago had exactly the same characteristics that can best explain the behavior of Sagittarius AAR today. A star approaches their current worth. The merger of two supermassive black holes has not yet been directly observed, but experts believe that this will change in the near future. At that point, gravitational wave detectors like the Laser Interferometer space antenna will be able to detect and examine the dance of the giants. If you search below our video, you can see the dance of the thumb and the subscribe button. Press the like and subscribe buttons now to ensure you never miss a new video from us again. Until then, see you soon.